Okay, so lesson 2, 3.2, solving quadratic equations by factoring. So up until this point, we've been looking at quadratic expressions. And so expressions is when we don't have an equal sign, whereas an equation means that we need that equal sign in there. So in our particular case, a quadratic equation is when we've got a term with an x squared, and then we can have an x term and a constant term. So in A, B, and C, we say that they can be any real numbers, so that fractions, decimals, whole numbers, positive, negative, it's all fair game. But A cannot be 0, and that's really a defining feature because we need this squared piece in order for this to be a quadratic. Okay, so we see that when A becomes 0, we get this equation instead. This is a linear equation, which we saw last year in grade 10. Okay, it looks a little different. It might also look like y equals mx plus b. That might sound a little bit more familiar. So examples of quadratics include 2x squared plus 3, but again we see that x squared, negative x squared plus 7, and just x squared by itself. This guy in particular, we call it the parent function, because it's as basic as we can get. So one option for solving these equations, because we've got an x squared and an x term, we're not going to be able to necessarily get our variable by itself. So that idea of like just isolating your variable, that's not really an option. Instead, what we can do is we can solve by factoring. So how does this work? Well, the general principle we're going to be using today and for this particular strategy, so we call the zero product property. What that means is that anything times 0 is 0, right? So you would agree that 5 times 0 equals 0. And 1,000 times 0 would still be 0. So if we know two numbers, A and B, equal 0, then one of them needs to be 0, or they both could be 0. So let's see what that looks like when we put it into action. So first of all, it says solve. That means we should end up with a statement x equals something. The following quadratic equation. So this is my goal, x equals. Well, we are only going to be doing solving by factoring today. So let's give it a shot. We've got, if we disregard the right-hand side, we know that's going to just stay as is. We factor this out. It's going to be plus 3 and plus 3. So we could even rewrite this hypothetically as x plus 3 squared equals 0. Either one is fine. Okay, but the idea is we've got two things multiplying together, two binomials multiplying together to equal 0. So one of those two pieces has to be equal to 0. So option 1 is that x plus 3 equals 0. Option 2 in this case is exactly the same. So I'm only going to solve it once. So I'm only going to have one solution. So that means that x must equal negative 3. Okay, and so that would be my answer. Okay, so again, because this product equals 0, do not drop that side, otherwise you can't solve something that isn't an equation. Okay, an equal sign can't come out of nowhere, so we need to carry it through all the way. So we try B. Okay, so we're going to try and factor it. I see it's a simple trinomial, so I'm going to jump automatically to this part. Okay, so factors of negative 21 that are going to add to positive 4. Okay, so x and x, that ends up being positive 7 and negative 3. Well, that means that either x plus 7 equals 0, or x minus 3 minus 3 equals 0. From there you can isolate x now that I've only got one x in the equation. So x equals -7 or x equals +3. And both of those are my answers. Are we feeling comfortable with this? Ready to try a complex trinomial? We'll give it a shot. We've got maybe using the crisscross method. I'm going to do it off to the side here. I need 2x to show up, so 2x times x equals 2x squared. Okay, I need -5, so that could be -5 and 1 gives me -5. Multiply diagonally gives me +x and -10x. If I add those together, that gives me -9x. So that gives me all three of my terms, so those are my two factors. So now I can break this down. 2x plus 1 and x minus 5 equals 0. Again, I have to split that then. So I've got 2x plus 1 must be 0, and or x minus 5 would have to be 0. In either case, I'm going to isolate x. Now, watch out here, I'm going to have to subtract 1, then divide by 2, so I've got -1/2. Over here, I've got x equals +5. So we can end up with fractions if we're dealing with complex trinomials. Well, what's wrong with this one? It's already done. I'm done. No, I'm not done. Why? Because of this part right here. Not equal to 0. And I don't have a rule about what those numbers have to be in order to equal 3. We want to say that the only factor pairs of 3 are 3 and 1. But what about all the decimals and the fractions and all sorts of other options that we have? We got too many options to choose from. So what we're going to have to do is we're going to have to expand or FOIL. And then we're also going to have to set it equal to 0. So first outsides, insides, last. And I'm going to get 2x squared plus 2x minus 3x is minus x. Minus 3 equals 3. But then I have to move that 3 onto the other side so that this side will be 0. And I'm left with 2x squared minus x minus 6 equals 0. Now I can use my 0 property. Okay, so I'm going to have to factor it from here. Now, luckily enough, this one isn't too bad. 2x and x, so my options are 6 and 1, but that's not going to get me anywhere near my middle term. So I'm going to go with 3 and 2. 2 times -2 is -4, plus 3 is -1. So breaking this apart, if 2x plus 3 equals 0, then x will be -3/2. In this case, x minus 2 equals 0, so x will be +2. So I've got two options there still. Okay, well, what about e? Well, it's not equal to 0. But why can't I just, divide by x? Okay, well, the second we start dividing by variables, we throw in this problem where what if x is 0? Are we allowed to divide by 0? Absolutely not. So we're not going to go that route, which means we got to move that those x's around so they're all on the same side, set equal to 0. So we get 2x squared minus 4x equals 0. I'm always going to default to make my x squared positive if I can. So that's why I moved everything onto the left in this case. From here, I want to factor. What's the first step in factoring? Greatest common factor. Thank you for saying that, even though you're just watching this independently. 2x goes into both of those terms and leaves me with x minus 2. Now this looks a little different in comparison to our previous questions because I don't have two sets of brackets, but I do still have two things multiplying together. Okay, term 1 is going to be 2x. It has to equal 0. Term 2 is going to be x minus 2 equals 0. Solve for x would be 0 here and positive 2 in this case. There we go. Okay, so that's kind of how we handle solving for x when we're dealing with a quadratic equation. Now we're going to learn multiple other ways to do this in future lessons once we get into different outcomes. But for now, anytime you're asked to solve for x, this is the only way we're going to be doing it. But with the idea of factoring and being able to solve for x, comes this idea of the remainder theorem. Now, this is something that you definitely see again in grade 12 pre-cal. And how it works is it says that if we have any polynomial, so that includes quadratics. Okay, so this is just my general function notation for an equation. Any equation where x is to the power of n and n is bigger than or equal to 2. Okay, if I'm asked if this is a factor, then my remainder is figured out by plugging in the number that's at the end. Now, we're going to rephrase this a little bit. Okay, so if you want to write this underneath, for our purposes, if any factor or any binomial is a factor of a quadratic, then P of our value, which is m divided by n, should be 0. So if I plug in my value of x, it should give me 0. And that's stemming from this idea that, well, my factor should produce 0 in my equation. So if it is a factor, it's going to give me 0. So it's kind of just building on that. So in this case, example A, x minus or x plus 3, that means that we're going to be plugging in the opposite sign. So that like x value. So in this case, x would be -3. Okay, so I'm going to plug it in. Let's see, does it work? Minus 15 is supposed to be over here. Okay, so I'm going to plug this value in. And we're going to chug along until we get to find out, does it equal 0? So 4 times -3 squared plus 12 times -3 plus 9. Well, that's 4 times 9. So be sure you're plugging in your value in brackets just so that you don't drop that negative and it ends up somewhere where it shouldn't be. Keep it all together intact inside those brackets. And then you apply the square, which makes it positive. In this case, for a second term, positive 12 times -3 is going to be -36, or subtract 36, plus 9. Well, 4 times 9 is 36, minus 36 plus 9. Well, that does not equal 0. So that means that x plus 3 is not a factor because it doesn't produce a 0 when we try and plug its value in. Oh, all sorts of typos in this question. Okay, B, is it a factor of this different quadratic expression? Well, we're going to be plugging in the same value. X is -3. Okay. So we're going to look and say, okay, well, 2 times -3 squared plus -3 minus 15. Well, that is the same as 2 times 9 minus 3 minus 15, which is 18 minus 18. So that does, in fact, equal 0. Therefore, x plus 3 is a factor of this particular equation. Okay, so that's the difference. You isolate your x, solve for kind of what it would be if this whole idea were true up here, and then you're going to actually plug that value in and check to see if it does work. So R5, our last outcome in this unit, is actually going to be integrated throughout all of our lessons. So we're seeing that here. So we're going to take our skills that we just learned, we're going to apply them to a word problem. So a dock jumping is a dog event in which dogs compete for the longest jumping distance from a dock into a body of water. So we're talking about some sort of structure coming off of the shore into water. And we've got our little dogs coming and they're jumping off of the dock and trying to see how far they go. Okay, so I always like drawing pictures when I deal with word problems. It's just a personal preference. Feel free to draw, feel free not to draw, whatever helps you most. So the path of a Jack Russell Terrier, this is just a type of dog, on a particular jump can be approximated by the function. Okay, so that means that this is just representing. And then our function notation equals all of this information, where h is the height above the water, so that's my output, my y value, so to speak. And d is going to be kind of like my x, if we were talking about graphing. So we can think about it looking kind of like this. Okay, determine the horizontal distance of the jump. Okay, well, the height above the water when it actually lands is going to be 0. So we're going to set this all equal to 0. Yeah, 0 equals -3/10 d squared plus 11 over 10 d plus 2. Now, we could factor out the 10th, but because we actually have an equation here, what I can do is I can actually multiply by 10, and it doesn't change my left-hand side because anything times 0 is still 0. So that's what I'm going to do. I'm going to multiply everything by 10. So we still have 0 over here, but now I've got -3d squared plus 11d plus 20. Now that might not look more manageable to you, but I know I certainly don't like fractions, so when I don't have to deal with them, I'm not going to. From here, the only thing I know how to do, I can't isolate d because it shows up here as a square and here is not squared, so not like terms. So I am going to have to factor all this out and see if I can solve for d. So this is going to be some weird factoring. You might want to take the negative out. What that looks like is you just change the signs of everything. So I'm going to keep that negative out here. Now that looks at least like I've got a positive d value. So again, I'm going to use that crisscross method. 3d and d would give me d squared. 3d squared. I've got 20, so maybe 5 and 4. would give me negative 20. That 5 is negative. Multiplying across, we've got d times 4 is 4d. 3d times negative 5 is negative 15d. If I add that together, I get 11d. And so I've got my two factors here and here. So 3d plus 4 or d minus 5. So working within this idea, d would have to be either negative 4/3 or positive 5 meters. Well, would it make sense that the dog jumped backwards if we're trying to jump into the water? No, it would not. So we're going to use our brains to think about this, and we're going to say that answer doesn't make much sense. So my final answer is going to be that the dog jumped 5 meters. Okay, so that's one way we can use this. Another way, under a different set of scenarios, the length of an outdoor lacrosse field. Now, a lacrosse field is long and rectangular, just like soccer, basketball, a whole bunch of other sports. The length of it, so that's usually the longer side, is 10 meters less than twice the width. So less tells me it's subtracting, okay, and twice means times 2. So I'm going to go 2 widths minus 10 versus the width, and that's going to be okay. The area of the field is given to us, so we've got a number. We need to solve this. Well, we know the area of a rectangle is length times width. From here, we can kind of plug in some values. If we've got 3 different pieces represented here, we can only solve an equation if there's only one variable. So what we're going to do is we're going to plug things in and see how it all shakes out. 6,600 meters squared. But instead of length, I'm going to plug in 2 widths minus 10 multiplied by my width. Well, now we're in a scenario similar to this example up here, example D, where we had it factored, but it wasn't set equal to 0. So we're going to follow the exact same steps to solve for the width of our field. So we're going to have to FOIL it out, get it equal to 0 so that I can use my 0 property, and then solve for W and L, because it asks for the dimensions with an S, okay? So it's plural. So we got 6,600 equals 2 widths squared minus 10 widths. Move that over by subtracting. We've got 0 equals 2 widths squared minus 10 widths minus 6,600. I've got a greatest common factor here. And again, I moved everything to the right this time so that I would keep my squared term positive. So I get 2w squared minus 5w minus 66. 3,300 now. Okay, and I'm going to have to figure out some factors of that. Ooh. Okay, so multiplies to give me 3,300. Well, I've got 33 times 100, but that's not close enough to give me a difference of 5. If I can go 66 and 50, well, that's closer. Okay, so give it a shot, see what you can come up with. Can you factor this? Okay, so when I get stuck in a scenario like that where I'm trying to find numbers that are close together, what I end up doing is I will prime factorize. So that's what you're seeing over here on this side. Prime factorization, and then I was like, okay, well, 66 and 50 is pretty close, so I'm going to try and find another factor that's close to that. So I went with 55, 5 times 11, and then all the rest of these pieces multiplied together give me that 60. And their difference is 5, so when they need to add to -5, I can do that if it's -60 and +55. So my final factors are W minus 60 and W plus 55. Am I done yet? No, because I haven't found my dimensions. So we've got the width could be either 60 or -55. Do we measure negative numbers? No, measurements are never in negative unless you're talking about temperature, but this is distance, so no negatives. So my width is 60 meters. My length is going to be 2 widths minus 10. So 60 times 2 is 120, minus 10 is 110 meters. So there we go. Those are my answers. Okay, so I know it's a number of steps, but the key idea is to remember it needs to be set equal to 0, and then you can factor. And we're looking for that 0 property, so 2 things multiply to equal 0. One of those pieces has to be 0. Any term being multiplied that has a variable in it is fair game for being set equal to 0. And that's what we see up here in example E. Okay, so even though it's technically not a binomial in the brackets, like we've seen in previous examples, it still is a term with a variable, so we still have to solve for x. So do some practice questions, feel confident about this so that you can do really well on those R1 assessments that are coming up.